We have two all-star panels ahead of us. The next one is going to talk about a kind of futurology and potential that seems weirdly underappreciated at the moment, but I think therefore is due for a revival. This is the potential of space to deal with the issues we've been discussing, which we all have to confront. This was the excitement of my childhood era, and I think it has potential to be exciting again. We have three wonderful panelists. One of them is Elon Musk, who's known in this business as the co-founder of PayPal. He also has been a leader in electric vehicles with Tesla, and for our purposes, he is a serious entrepreneur in space travel. His SpaceX company has won the competition to design and build the successor to the space shuttle when it retires. The other is Peter Diamandis, who's been for 20 years a leader and pioneer in the business of personal spaceflight. He arranged, among others, the recent trip of Charles Simonyi to the space station. He's the chairman of the X Prize Foundation, which offers cash prizes for breakthrough innovation. The moderator is the universally known and admired John Doerr of Kleiner Perkins. So please join me in welcoming our three panelists.
Good afternoon, and it's great to see all of you, especially in an intimate setting like this. It's going to be fun. We're talking with two amazing entrepreneurs, two rocket scientists, two visionaries, and a struggling venture capitalist who's always looking for great entrepreneurs like I'm seated next to today. Peter Diamandis is the head of the X Prize organization. He's an adventure capitalist in his own right, and we'll hear in a moment about the innovation that he's been able to inspire with a very innovative way of getting corporations, not just individuals, to go after great grand challenges. Besides the X Prize, he's also the founder of Zero Gravity Company and another firm called Space Adventures. We'll hear from him in just a second. And then we have Elon Musk, who is a founder of PayPal and now the chairman of Tesla and of Solar City, but has come with us today to talk about Mars and why we would go to Mars. So as we begin these conversations, I understand you can text questions. You can start doing that right now, so we cover them in our conversation. And I've asked both Peter and Elon to kick things off by telling us one thing about themselves that almost no one knows.
Great. I guess at the age of 8 or 9 years old, I probably had about 20 pounds of potassium perchlorate, sodium, magnesium, potassium nitrate. I was probably a teenage or a sub-teenage terrorist. I'd be arrested on the spot right now. I used to build my own rockets, and I'd get 5-pound boxes of potassium perchlorate, which has a great, it generates its own oxygen. It's so you can blow it up underwater. It's really cool.
And what was the most explosive event?
My friend blew up his hand. He was fine. He's fine. But second-degree burns. It's hydrophilic, so he was crushing it.
And did you provide him the gunpowder?
We were sort of building our rockets together.
Yeah. Rocket boys. Elon?
Wow, I had almost exactly the same experience. And a friend of mine also burned his hand. Wow.
But tell us something else about you.
So I've been to Burning Man 9 times, and I have an electric rocket art car.
Burning Man 9 times, an electric rocket art car.
Yeah.
Did you take that to Burning Man?
Yeah, absolutely.
Did it come back?
I think so.
Did it win an X Prize while it was there?
yeah, in a manner of speaking.
Yeah, very cool. So there's a common theme here. They're crazy, and they're both interested in space. Why space?
Well, I think that everything we hold of value on this planet, metals, minerals, energy, real estate, is in near infinite quantities in space. The first trillionaires will be made in space. And I think I don't want to steal Elon's thunder, but I think it's a moral obligation for the human race, some small percentage of us, to be thinking about where humanity needs to go next. I have two halves of my life, if I can just speak for that before entering this video. One is the X Prize Foundation, in which we look at what are the biggest challenges we have in humanity. What are the problems? And how can we incentivize those with a large cash prize that says, I don't care where you're from, where you went to school, what you've ever done. If you solve this problem, you win the money. And we did that first with the Ansari X Prize for spaceflight that no one believed it could be done. In fact, we funded it with a hole-in-one insurance policy because the insurance company believed it was impossible it would ever be won. And we have 4 areas: exploration. We are doing space with the Google Lunar X Prize. Google's the sponsor of that. As Sylvia knows, we're going down to oceans, and she's chairing our Oceans X Prize steering committee. Thank you, Sylvia. In life sciences, we have an active prize called the Archon X Prize for genomics. First person to sequence 100 genomes in 10 days, and Craig Venters are heading that up. And then energy, the environment, and global development. And my other half of my life is trying to create the markets in space, taking people there. So we fly people in zero-gravity flights and in orbital flights to the space station.
And do you give miles?
Not yet.
Not yet. So there's a video you want to show.
I'd love to show a short video to punctuate some of those and give you visuals. So if we could run the first video. Some Ansari X Prize footage from 4 years ago. So this is Spaceship One flying on second time to 100 kilometers, built by Burt Rutan, funded by Paul Allen. We had $100 million spent to win a $10 million prize, and there's been arguably over $1 billion invested. We have our Lunar Lander Challenge. John Carmack, you might know, is going after this. This is launching capabilities equivalent to landing on the lunar surface. And of course, the $30 million Google Lunar X Prize. We have, at this point, 13 registered teams. We've had over 1,200 teams from 70 countries around the world. And this is, all you have to do is go to the moon, land, send back a mooncast, row for a half a kilometer, and send back another mooncast. Mentioned Zero G. Here we are. We flew Stephen Hawking last year out of the Kennedy Space Center. Some images of him. He had an amazing time. We planned to do 1 parabola. We ended up doing 8. Somebody you know who's been flying with us before. And on the orbital side, we've flown 5 people to orbit to the space station with the Russian Soyuz. Here it is. Our 6th customer is going up next month. And this is really, can we create the marketplace and get it out of the hands of the government into the commercial markets? So.
Can we?
Oh, absolutely. No question about it. It's just a matter of creating the marketplace that brings capital like yours into it. It's creating the gold rush and the land rush again. There is huge value. An average half-kilometer asteroid is worth something like $20 trillion. But we'll get to that later.
We'll come back to that. Elon, why space?
Sure. So I think space is extremely important. But first you have to go to the definition of importance and say, why is anything important? And if you use the lens of history and you zoom out far, I think you can distinguish the less important from the more important. And if you zoom out really far and look at the 4 billion year history of Earth and the evolution of life itself, and say, what are the major milestones in the evolution of life itself? I mean, obviously there's single-celled life, multicellular life, there's differentiation of plants and animals, there's life going from the oceans to land, there's mammals and consciousness. There's maybe a half a dozen or so really big milestones in the history of life. And I think on that scale, it would also fit the extension of life to multiple planets. It would be at least as important as life going from the oceans to land, and arguably more important because you could easily, if you're going from oceans to land and got a lot uncomfortable on the land, you could jump back in the water. But that's not something you could do with going to another planet. In fact, I think extending life to multiple planets really requires consciousness as a precursor. So if we've got something that's so important that it would fit on it'd be one of the half dozen or so most important milestones in the history of life itself, that's pretty darn important. And it goes beyond the parochial concerns of humanity. It's something that is of importance to life in general. So that's why I think it's important to do. And this is the first time in the 4 billion year history of Earth that it's been possible. So how long will it remain possible? I mean, if things go well, obviously it will be possible for a long time. But if things if something unfortunate were to happen, it could, that tiny window that just opened for the first time in 4 billion years could close.
So your notion of space and time is we got to get there now and be able to stay there.
Yes.
Because we may not be able to go there again.
Yes, exactly. I'm actually an optimist, so I actually think that things will go fairly well on Earth. And this is not to suggest complacency, because there are very important issues, the climate being probably number one in terms of earthly issues.
Yeah.
But I think if this is the first time in 4 billion years that life has had the possibility of doing that,
yeah,
we should take advantage of that little window, and just in case it does close, because extending to multiple planets is gives us the surest chance of life lasting for a very long time, because there's always the possibility, certainly life as we know it, of some either natural disaster or potentially man-made disaster that extinguishes life, and that would be bad.
Probably. Probably so.
Yeah.
You have a video you wanted to show us?
Yeah, absolutely. We can roll the. This is a SpaceX video, which is it was actually done by SpaceX in collaboration with NASA, so I don't know if we can play it. But
We roll video 2 from space. Thank you.
yeah. So this is courtesy of NASA, who paid for the video. The launch pad you see there is Launch Pad 40 at Cape Canaveral. So that's where we'll be launching our big rocket, the Falcon 9. Next year will be the maiden launch. Here doing stage separation, second stage ignition, and then separation of the Dragon spacecraft from the second stage. Now approaching the International Space Station. This is a real physics simulation, so this is not an artist's impression or something like that. This is all the real engineering solid models of the station and of the rockets, and with real physics involved. So,
What does it cost to make one of these rockets, the Falcon
well,
9?
the price.
In high volume.
Well, it could be much lower cost in high volume, but the price for Falcon 9, the booster is about $40 million, and it's actually about the same for the Dragon spacecraft, because there's a lot of complex avionics and docking systems and so forth, even though it's relatively small, which is not too bad. I mean, it's comparable to a corporate jet.
Right.
And actually, in the world of rocketry, those
It's a bargain.
That's a really
Elon,
low
how much
cost.
would you pay for a Lockheed or a Boeing booster of the same capability?
About 160 million.
That's
Right.
pretty good.
So we're about a fourfold difference from
75% off.
Yeah, absolutely.
And this is a for-profit business.
It is. In fact, we've been profitable for the last 2 years.
Really?
Yeah.
So let's go to
that
this-
may be the neatest trick in rocketry.
Let's go to this original question, why space, from the following lens. We're going to hear in a little bit from Al Gore, we have a planet that is in peril.
Yeah.
Can you connect the climate crisis to space? Or
Yeah,
are they really separate
Well,
agendas in your life?
definitely if we are able to establish life on another planet, which is like Mars is the only realistic possibility, and it's very difficult. It requires us to learn a lot about climate and maintaining the climate equilibrium. So there's a huge amount that we'd learn in trying to establish life in a hostile environment,
Right.
that we could translate back to Earth. So I think there is that connection. Yeah. And then of course, if things do really go to hell in a handbasket here, at least
a few of us
life is
there.
not. We've backed up the biosphere,
But you're not more concerned about the primary store here?
Well, I think the most important earthly problem is climate.
Yeah.
But if forced to choose, I would say establishment of multiple planets is more important. But this is sort of like saying, do you like your mom or your dad more? It's somewhat of a awful choice to make. So.
Correct. The two of you disagree on one thing, and you're very excited about Mars, and you're very excited about
Getting out of the gravity well of Earth, I think.
zero gravity.
Well, basically, getting out of the gravity well of Earth and being able to build the biospheres, the facilities, if you would. There's a line of work by Gerard K. O'Neill talking about building civilizations and such out of the asteroids and the asteroid belts, and instead of getting back into the biosphere or the deep gravity well of another planet. But once you can do one, you can do pretty much the other. I think if you're trying to solve all of Earth's problems within the constraints that we have, you're limiting yourself where you don't need to. We don't have the resources we need to bring everybody on the planet up to the standards of living that we have here in America. And I think that being able to look at space the same way that we looked at Alaska, we purchased Alaska in 1800, Seward's Folly, as this distant, desolate wasteland. And then we build the roads to get there, and now we extract energy.
The bridges.
To nowhere.
To nowhere, and to Russia. It's very close by.
But on a serious point, when we build the infrastructure to get there, we now extract resources that benefit the rest, and we'll do the same in space.
We'll bring resources from Mars back to Earth.
Not from
Come on.
Mars. Not from
Come on.
Mars.
Do you offer miles? Maybe. Okay, questions, you can text those to 90822. And
So I have an announcement to make here today.
do we have any news?
Yeah. Oh, yeah.
I do. As you know, we are in the business of getting people to the space station. We offer a seat and we offer a backup position. And somebody here in the audience is going to be training in Moscow very shortly to go to eventually fly. And if that person would please stand up. Esther
Hey.
Dyson. So we are looking forward to offering Esther frequent flyer miles as she goes to Moscow to train.
Esther, what were you thinking when you decided to buy that? Can we have a microphone here, please? Thank you very much. Oh, right there. Excellent.
Well, when I was growing up, I fully expected to go to the moon, but I didn't think I'd need to do anything in particular to do it. And then I got distracted by some other interesting things. And now I have the chance to not yet to go up. But you know the old joke about God, please let me win the lottery. And God says, so did you buy a ticket? And I'm buying a lottery ticket. It's only a backup because I can't afford the 40 million, Peter. Maybe it will go down with volume.
But you should remember that Anusha Ansari was the backup
I know.
for Japanese, and he got ill, and she went to orbit.
I'm remembering.
One out of 5 chance. That's pretty good.
Is the backup deposit applicable to a full flight?
The backup deposit, that vehicle
It should be.
The vehicle is going with or without, and we'll cut Esther a good deal.
All right.
It depends on the timing.
Okay. Very, very cool. Any other news? Elon,
sure.
what's late-breaking news?
Yeah, well, actually, one thing I forgot to mention is like the naming of Falcon 9 and Dragon. You know, why we name our booster Falcon and one Dragon? So Falcon's named after the Millennium Falcon from Star Wars,
right,
because Falcon can do the Kessel
Chewbacca.
Run in 7 parsecs.
Wookiee. Yeah.
And then Dragon was actually named after Puff the Magic Dragon. Because so many people thought I was smoking weed to do this venture. So,
And the next name will be?
yeah, good question.
Yeah.
I don't know, but something like that.
Suggestion, nominations for the name of the next spacecraft. You just put your hand in the air, shout it out. Yes. Bristol. Bristol. Why Bristol? Palin? Palin, there's a good name. Back there, yes, Larry Brilliant. Lucy in the sky with diamonds. Okay, so we have some questions. Yes?
Actually, sorry, and there is a news item, which is that the next Falcon 1 launch is on the launch pad on our island in the Kwajalein Atoll.
On the pad now.
Yeah, on the pad right now.
There was one that went up that didn't go all the way.
We've had 3 sort of test launches so far. The Flight 2 and 3 made it to space, but not to full orbital velocity. So we're hoping Flight 4 makes it to full orbital velocity. And we've not yet put out a press release or anything, but we'll publish something on the website probably later today that the next Falcon 1 flight is on the launch pad on our island in the Kwajalein Atoll, and that it will be launching in about a week.
Excellent. Well, you heard it here first. Let's go to some questions. Here's to Elon. When will there be life on Mars?
Oh, when? I think it's possible we could send the first people to Mars within 15 to 20 years.
And what do you think it will cost then when people are buying tickets to Mars?
It's heavily dependent on the launch rate and whether we're able to make a fully reusable launch system. In fact, the fundamental breakthrough that's necessary to extend life beyond Earth is a reusable launch system, and that's never been achieved, even for low Earth orbit.
Yeah.
No one has ever made a reusable system. And
Is Jeff Bezos building a reusable launch system? Blue
Yeah.
Ocean or whatever that is?
I think he is. I mean, Jeff and I have almost exactly the same philosophy as far as the importance of extending life beyond Earth.
Yeah.
But what Jeff's doing is suborbital, and suborbital is much easier than orbital. In fact, to give some sense for this, to do a suborbital flight, you need to get to about Mach 3.
Mm-hmm.
To do an orbital flight, and that's just below Earth orbit, you need to get Mach 25.
Wow.
But the energy required goes as the square of the velocity.
Right.
So you only need 9 units of energy in one case and 625
Hardly
units of
even
energy.
in the business, right?
Yeah, basically you need less than 2% of the energy to get to do a suborbital flight.
Yeah.
And then of course, if you want to re-enter and be alive, you need to shield yourself against that energy because you come in like a meteor.
Like a meteor or an
Yeah.
asteroid, which actually goes to the next topic. Peter, you said something about an asteroid is worth $1 trillion, which got my attention. These things regularly come in and burn up, don't they?
They
Or those are
do.
meteorites.
No, we're basically bombarded by small
Small
rocks
asteroids.
that burn up in the atmosphere. But there's millions of asteroids of various sizes. Some become very close to the Earth. And they come in different shapes, flavors, and sizes. Some are carbonaceous chondrites, which are dirty ice balls. Others are nickel iron. And some of them are basically past planetary cores that have on the order of a 50,000 time enrichment in platinum group metals over our platinum mines here. And an average half-kilometer size asteroid of that type is worth somewhere between $20 to $30 trillion. Now, my plan is...
Do we have that much demand for platinum?
Well, my plan is actually to buy puts on the market and announce the mission, and then finance it and go. But a half-kilometer asteroid of that type represents all the platinum that's been mined to date.
Are your transactions going to be federally insured? So, do you guys believe in life on other planets?
Do you mean, do I believe that there is life?
Yeah.
I think there's a high probability of some kind of primitive life form somewhere on other planets, but it's most likely bacterial. If you look at the history of life on Earth, it was really pretty much simple, single-celled primitive bacteria for the vast majority of the time, and then there was a sudden explosion into multicellular and more complex life forms. But do I believe there's intelligent life out there that's perhaps within reasonable or any kind of possible reach of Earth?
No, I meant anywhere.
Okay, anywhere in the
out
entire
there.
universe?
That's right.
It's probably more likely than not, but that's a complete guess.
Complete guess.
Sorry?
Complete guess.
I hope there is, but we have no evidence right now of any life whatsoever other than on Earth.
I think life's ubiquitous in the universe. I think it is a force of nature. If you look at the elements required to form life, like human life, we had that 2 billion years into the evolution of our stars. Our planets started basically 10 billion years ago. It's 5 billion years. We have intelligent life 4.5 billion years into our process. So life could have had an 8 billion year head start in other parts of the universe. So I think it's ubiquitous. I think that's a long conversation.
But where are they?
We don't talk
Among
to little
us.
bacteria in the...
Let me come back to imperiled planet Earth. What can we learn from what you're doing that's directly applicable to the climate crisis?
Right now, in the space stuff,
Yeah.
well, definitely space has been very helpful in assessing the state of the climate on Earth. I mean, the satellites up there that measure the oceans and atmosphere have been critical to our understanding of the changes that are taking place on Earth. So, I mean, at SpaceX, we will be launching some of those satellites in the future. So I think that's perhaps in near term directly applicable stuff.
Well, the conversation we just had with Vice President Gore in the green room, talking about the fact that being able to visualize Earth and do the energy balance, you can't fix what you can't measure. And so one of the very first things is to get his satellite, Triana, or some other commercial satellites up there ASAP So we have the data set to understand.
Or as Andy Grove said, and Intel behaved, if you don't measure it, it doesn't matter.
And it's true.
Yeah.
Absolutely.
Let's close with the following. How about a 20-second update on Tesla?
Wow, okay. Tesla, in production at 10 cars a week with the Roadster, just announced a 90-acre headquarters in San Jose. And
How many have been sold?
1,200.
1,200 orders for
Roadsters,
1,200.
yeah.
And the price is?
109,000.
And if I ordered the 1,200th in one, how long would it take to get?
About 10 months.
10 months. And if I multiply those numbers, I get the revenue.
Yeah, probably 200 million next year or something like that.
Yeah, Terra million?
200 million or
200
so,
million,
yeah,
yeah.
next year.
Peter, the most exciting 2 X Prizes?
The goal right now is to do something significant in the energy environment space. We're looking at, in life sciences, cancer, and healthcare. We'll be announcing something big there shortly. And so it's exciting to say, what do people care about? Where can we launch in the future very large cash prizes that change the way people view problems?
Yeah. Well, let the games begin. Let the prizes be awarded. And friends, join me in thanking both Elon and Peter.